So let's write this out generally. So closed interval notation for continuous functions can be written two ways. We write the independent variable, and then we write this funny looking e, which means is an element of. And then for closed interval notation, we're going to use brackets. So we're going to say a, comma, b. So that means that x can take on any value between a and b, including a and b. The endpoints are included because this is a closed interval that uses these square brackets. Another way that we can write the same thing is with this notation, with less than or equal to signs. These mean the same thing. So this notation says that x has to be between a and b and can take on any value between a and b, including a or b. So it's that less than or equal to, that tells us that we can include the endpoints, which is the same as using those square brackets. For interval notation, here we'll do this one with t. So let's assume our independent variable is t. We would say t is an element of little a, comma little b. So here, the open interval notation is what's important here. It's these parentheses. The parentheses tell us that we're looking between a and b, but we cannot include the a and b. So we will strictly be between them. So if a is 1 and b is 2, then t can take on values like 1.1, 1.2, but it cannot take on the value of 1 or 2, just things between them. We could similarly write this using the notation of strictly greater than or less than. So t has to be between a and b, and as long as you don't include the and equal to part of the inequality, these mean the same thing. So that's open interval notation for a continuous function. So when we're ever considering how we're going to write our intervals, we need to consider whether or not we're including the endpoints. And again, when you talk about infinity, we always use open interval notation. So let's try a couple more and see if we can figure out these intervals for the domain and range using our new notation. So next, we're going to consider a graph. So assuming that the entire function is pictured below, find the domain and range for this function. So if the entire function is pictured below, that means that it does not continue past what we see. And therefore, we can cut off our graph in terms of the independent variable because we don't have these arrows on the ends. So let's start with the domain. So the domain is all the possible x values. So here, my x values, they start at -2, and then they continue going. My function continues going all the way until I get to the other endpoint, which is at x equals 2. So my domain here, I'm going to write as x is an element of -2 to 2. And I'm including the endpoints because they are defined here and they have a defined y value. Again, I could use the alternate notation, and I could say x is greater than or equal to -2 and less than or equal to 2. Both of these are good ways to represent the domain. Now that I have my domain, I want to consider the range. So the range is the possible y values that I'm going to get from this function. And so here, if I look at my y values, I can see they go as high as 4, including 4, and as low as -4, including -4. So therefore, my range is going to go from -4 to 4 because I can get all the values in between, which we can see here. And again, if you prefer, you can use inequalities here. And since I'm including the endpoints, I will use less than or equal to and greater than or equal to symbols to represent that. So again, we can get domain and range of a function on the graph, and so far also on a formula. Now let's consider what happens when we have a table. I hope you already have a sense that we're going to have to do something a little bit different because tables are not continuous. So assuming that the entire function is represented below, find the domain and range for this function. So the domain here is going to be the values that t can take on, because in this particular example, t is our independent variable. So here, t can take on the values of 0, 1, 2, and 3. So my domain here is those values, 0, 1, 2, and 3. And then my range is going to be the values that f of t can take on. And that's -1, 1, 7, and 17. So what I need to do is think about how I'm going to represent this. So we have a little bit different notation when we talk about discrete functions. So for discrete functions, we're going to use curly brackets, and we're going to list the values that these things can take on. So for example, here, t is going to be an element of, and now I'm going to list all the values that t can take on. So 0, 1, 2, and 3. So I'm listing the set of numbers that are available for t to take on to represent my domain. Similarly, I can do the same thing for my range. My range is going to be f of t, and I'm going to list all the values that f of t can take on. So -1, 1, 7, and 17. So these are the values for my range. So interval notation for discrete functions are going to list sets of numbers. So usually when we do this in general, we say x is an element of, and then we say something like n sub 1, n sub 2, n sub 3 to represent the different numbers that x can take on. Same thing when we talk about the range. So again, we're going to list the numbers that y can take on as values, or the dependent variable can take on as values, in the curly brackets and as an ordered list. We write these in order generally from the smallest value it can take on to the biggest value it can take on. So that's the notation that we're going to be using for discrete functions in this course. So finally, let's go to our word problem, our description, and see what we can say about the domain and range here. So the cost of ice cream, C, in dollars at the local shop in Mathtown, Ohio, is a function of the number of toppings T ordered to be put on the ice cream. So that's what we had before. But now we have some additional information. If the shop offers 10 different toppings and the cost of an ice cream is given by 5 plus 0.25 T, what is the domain and range of this function? So now we have more information than we had before. So now we've given more shape and information to this problem, and we can now start talking about different things. So the domain here are the different values that we can pick for the independent variable. Remember, your independent variable here is t. So when we talk about the domain, we're going to list it as t is an element of. Now we have to consider the different values that t can take on. Now here, the shop offers 10 different toppings. So that means we could take 1 topping, 2 toppings, 3 toppings, 4 toppings, all the way up to 10. And we also, if we wanted to, could get 0 toppings if we weren't that interested in what they were offering. So our values here are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are the values that t can take on. So that's going to be our domain, and that's how we can write it. Our range is going to be the possible costs that we could encounter at this ice cream shop. So that means for each possible value of t, there's a corresponding value of c. So in order to figure out what that value is going to be, we would need to plug each of these independent values in to get the dependent value. So for example, if we plugged in t equals 0, our very first possible number for our domain, we get c equals 5. Remember, c is cost, so that 5 represents dollars. So $5 is one possible output. If we plugged in a 1, we get $5.25. If we plugged in a 2, we get $5.50. If we plug in a 3, we get $5.75. If we plug in a 4, we get $6. If we plug in a 5, we get $6.25. If we plug in a 6, we get $6.50. If we plug in a 7, we get $6.75. If we plug in an 8, we get $7. If we plug in a 9, we get $7.25. And finally, if we plug in a 10, we get $7.50. So this is the whole set of possible costs or possible outcomes, which is the range of this function. There was a lot of data to write here, but since it's a contained set, we were able to write them all out. So that's how we would represent the domain and range of a word problem. We'd consider what the function was and think of all reasonable domain numbers, and from there generate the range numbers.